Thank you, everybody, for coming today. Lovely Sunday and spending your time here. That's excellent. Wonderful. I'd like to thank Srijan for organizing this talk. As usual, wonderful to be back in Delhi. So today, like talked on Indic roots of modern knowledge systems. And even before I start the talk, I'd like to clarify, anticipating certain pushback on this. There are people who say, am I being excessively jingoistic by trying to say that Indic knowledge came from, most of the world knowledge systems came from India? Is that what I'm trying to say? Things of this nature. And I assure you not. I'm a person who's primarily seeing the existing narratives, deconstructing them, and trying to see, is there an alternative narrative that fits the evidence? And I'm presenting to you whatever that is. So if you've seen my earlier talks, you'd perhaps appreciated the antiquity of the Indian civilization. I'm not going to be repeating that over here. So it's a given that the civilization is pretty ancient. People have been around in India for a pretty long time and have had time to encounter problems or issues or ideas that confront the human civilization and propose solutions to them. So that's the main reason you find that a lot of knowledge systems came out in India. So I'm going to be talking about technological heritage, mathematical, astronomical, medical, and music. So in ancient Indian philosophical systems, we had talked about this earlier. I won't talk much about this, but this is a prelude. This is a prelude to tell you that here's a civilization that placed great emphasis on the generation of knowledge. So the knowledge generation was pramana, and different schools of thought came up with different ideas on what are the admissible paths for knowledge systems on Nyaya, Yoga, Vaisheshika, Samkhya, Purvamimamsa, Vedanta, and Jain and Buddhist works. And most of the knowledge systems of the ancient past only differed in what was admissible as a source of knowledge. For example, the Charvakas said perception alone, only if we can see it, then it's something that is valid. So they rejected the Vedas as a source of knowledge. They said only direct experience is what gives rise to knowledge. That is their way of looking at things. Buddhism looked at perception and inference, which is echoing the journey of Gautama Buddha. He went through some trials and tribulations on his path to nirvana, and so it reflects that kind of a system over here. So you see that what I presented in the earlier page, Samkhya, Nyaya, Vaisheshika, Mimamsa, Advaita, they only differed from the admissible schools. Samkhya was perception and inference, Nyaya took this, and comparison and analogy, and so on. So when you go, by the time you reach Advaita, it's pretty open in trying to take different pathways to knowledge. That's the way to put it. So the example that I give is in today's world, if you're doing your PhD thesis, you typically might want to refer to some professor, maybe from Berkeley or Harvard or some such place, and he might say that he has proved a certain theorem in his works, and on the basis of his theorem, reference 1, I'm going to prove my theorem, and my thesis is based on that work. So you're relying on the Shabda Pramana of some professor who came before you. You have accorded or privileged his ideas as really good, and you take that as an authentic source of knowledge. Based on that, you write your thesis. That's the way we do it today. But in the ancient Indian world, depending on the sampradaya in which you belong to, various means of admitting knowledge were present. That is the bottom line. Given a comparative outlook on life, primarily to see the conduciveness to knowledge. Not all cultures had a philosophy that was conducive to knowledge. So at a very high level, I have the dharmic and the Western Abrahamic categories over here. Goal of life was to dispel avidya, journey across lifetimes, aware of karma, dharmic living, and the goal is to attain moksha, whereas here it was to follow a divine dictated law for judged admission to heaven or eternal damnation, and you have one life to live. That is the philosophy of life over there. These big questions of today, how do the dharmic people and the Abrahamic people encounter that? Theory of evolution, we are enjoined in dharmic systems to use the darshanas to appreciate whatever is vidya and avidya and make sense of theory of evolution. Whereas over here, it's against the history centricism of creation, that creation was a God-mandated event at one particular point in time. God created the universe and so on. Climate change, we understand our role in contributing to carbon, and if we reduce the carbon footprint, I say that's equal to reducing our karmic footprint. We understand our karma and live dharmically. So if you can afford to drive let's say a hybrid or an electric car, you do that rather than driving a gas guzzler. You have a conscious choice on what you choose to make out of life. So in the Abrahamic way of looking at things, God has put man in charge of creation. Thus, this has led to unabated destruction today, and there's a tendency to deny climate change because climate change does not exist. God has put you in charge of everything. Sustainable living and compassion for all life. We recognize the Atman in all life, live dharmically, mindful of the karma that we are generating. Over here, man has sovereignty over all life. Animals have no soul. Therefore, there isn't compassion to animals and we can exploit at will. The issue of an ancient earth, we can use darshanas to appreciate Vidya and Avidya again due to history centrism of creation. The earth is not ancient in this way of thinking. And tomorrow, if there is life to be found outside earth, then we would again have no problem in the dharmic framework, appreciate using Vidya, Avidya. Whereas in the Western frameworks, due to history centrism of creation, there would be some problems over here. So the bottom line is I'm trying to show what is the outlook on life and is it conducive to knowledge or not. So that said, I'm going to now breeze through the conclusion of my talk because I don't think I'll have time to get to the conclusion. So I will straight away talk about the conclusion. So the roots of medicine, we see medicine roots in Atharva Veda, which led to Ayurveda. Charaka, Shushruta Samhita were compendiums of Indic medical knowledge. The Mitannis, Hittites, Egyptians, Chinese were influenced by Indic systems. Medieval Europe depended strongly on drugs from India. Arab medicine based on Ayurveda since Bin Qasim's invasion of Sindh. Ayurveda formed a corpus of European knowledge right through the colonial era. And Ayurveda was taught in British medical schools in India till 1880. Until such time, their own systems came up, the digestion of Ayurveda was complete, and it formed the core pharmaceutical methods in the system. I'm also going to be touching on mathematics. And it's very pretentious to try and say I'm going to cover all of Indic knowledge systems in a 1-hour talk. I mean, that is very insulting. So there's no way we can do it. So there's going to be snippets here and there. So math had origins in the Vedas with number systems, large numbers, operations. We know about the Silva Sutras of Baudhayana, showing greatly refined knowledge of geometry, square roots, and so on. By Aryabhata's time, we have greatly refined trigonometry, spherical geometry, and algebra. Surya Siddhanta shows intricate math and astronomical knowledge and refers to extinct Siddhantas. We'll talk about that. By the time we come to Brahmagupta, Bhaskara 1 and 2, greatly added to a corpus of works on algebra, positional math, zero, and so on. Kerala School of Math greatly refined astronomical models and developed the essence of calculus. And right down to our times, Ramanujam continued the tradition of Indian mathematicians with deep results in infinite series. I'd like to also talk on the roots of music. So I'd like to talk to you about how the earliest musical systems originated from the Samaveda. The three-tonal liturgical music in Samaveda gave way to the 5-tone, to the 7-tone, to the 12 semitone scales. We'll talk about that. Musical intervals are based on chord ratio. This is not a C-H-O-R-D, this is a C-O-R-D, chord, Silva Sutras, chords, chord ratios. Pythagoras used the same ratios and is originator of the Western musical traditions. We will talk about Pythagoras and how he used certain ratios for music, considering it to be divine, and erected a statue for the goddess of music. Muses will talk about that. Talk about roots of astronomy, where initially astronomical knowledge embedded in stories. Then we went to heliocentric model, which is encoded in Satapatha Brahmana and Aitreya Brahmana, used by the Greek Aristarchus. Gave way to Siddhantic astronomy, and many of these works are lost today. Mathematical models to estimate the course of sun, moon, and planets. Development of trigonometry, spherical geometry. This is also used by the Greeks. Models to estimate eclipses, duration, length of shadows, Aryabhata. Estimation of circumference of the earth and curvature, Brahmagupta. And the rate of precision, Bhaskara 2. Model for partial heliocentrism, Nilakanta Somayaji. Copernicus was influenced by Aristarchus, who was influenced by these works, and he exchanged the position of sun and earth in the known models, and he came about the heliocentrism. Many centers of learning were destroyed in India by Muslim invasions, and the last great classical astronomer was Pathani Samanta Chandrasekhar, and we'll talk about that. Then the roots of our modern systems. So today we cannot live in a world where you are not digitally connected. If you're not digitally connected, it's like you don't exist. So the basis of everything is in digital systems, whether it is computers, cell phones, internet, and very, very pervasive digital systems. The Nasadiya Sukta has got examples like this A and not A in its kind of logic. This is very, very clearly a Boolean algebra kind of a formulation. And this is not the only one. When you go to Nyaya and other schools of logic, you'll find that there's a lot of logical statements encoded in them. So Colebrook wrote a work on Indian logic in 1824, and this work greatly influenced these two gentlemen. This is De Morgan and this is George Boole. So anybody here who's an electrical engineer will recognize these names because these were the people who wrote the algebraic theory of Boolean algebra. Once that was done, then it was very easy to progress from there on to technological innovation. So it influenced George Boole and De Morgan. And Boole's wife, Mary Everest Boole, wrote a letter to Bose outlining the influence of Indian logic on Boole and De Morgan. So the use of Boolean algebra is what has enabled the design development of complex digital systems. So the key over here is not to claim that Indians invented anything. There is no Indian who invented the transistor. The transistor was invented by Shockley. So we know that. We know that. So, but the point is, ideas don't come in isolation. We live in a connected world. Ideas go from one place to the other. Ideas germinate our thinking. And from that thinking, we move on to something else. You all know that when you're discussing with your friends, suddenly you get a brainwave. But if you're sitting in your room working alone, you probably would not have chance on that kind of thinking. So that is what I'm laying out a path for, saying that Indian knowledge systems seeded world knowledge systems. And so we are the recipients of a knowledge system starting from a trajectory from the ancient Indians. That's what I'm trying to emphasize over here. So I'd like to very quickly set the stage by showing you lovely pictures. These are pictures that will demonstrate the technological prowess of our ancestors. So here's a lovely temple. The lights were off, you could make out. This is the Rani Ki Vav, as you would have noticed it, and 1050. Observe how beautiful the layout of this whole thing is. Brihadishwara, many of you would have heard about Brihadishwara in Thanjavur, and built in 1010. Lovely temple, maybe the biggest temple I've seen at least. I don't know, there's a bigger one in India. It's called Periyakovil for a reason. It's a very big temple. In Maharashtra, Ellora, I don't believe this date. I just read a work yesterday where a person talked about some Greeks mentioning the Ellora caves around 260 or so current era. So there's no way I trust these dates. So we know about this very lovely rock cut temples. It's an engineering marvel if you look at it. And in Halebid, I apologize for the quality of the picture, but then these appeared to be pillars that are turned on a lathe, very, very smoothly done, very round and so on. This is in Rameshwaram. It was built in the 11th century and once again in 1750. And you can see how there's vanishing lines, parallel lines, as you can see, lovely perspective over here. And this is one more, Konarak, Odisha. We know about this also. Now, when you see these things, the first thing that must come to your mind is, how did our ancestors build these things? Is it that the king gave some money to the people who do these things and they took some chisels and started working on it? How did they do that? Because today we know that if you're going to build a huge building like this, you go to a CAD or somebody who does computer-aided design, does the layout, does the engineering calculations, does how much of a load can each pillar take. Based on that, we build buildings today. How did your ancestors do this? That is the question. To my surprise, I found that they were using engineering scale diagrams way back in the 10th century, way back in the 9th century. This is from a talk with Professor Arun Iyengar. You can Google for this and find it on YouTube. And he shows this particular work. There's a book over here out of which he shows these pictures. These are all palm leaf diagrams. So you can see that each of these is a palm leaf diagram. And these palm leaf diagrams placed one below the other gives you a perspective of the entire temple as such. And if you look at this in detail, there is actually detailed calculations that show you how each section should be built. Even the wheel at Konarak, detailed instructions on how that wheel should be built. And not just that, if you go, you can see deeper and deeper into these works, it even talks about how much of work is involved, how much of money to pay this. So in other words, engineering work order, it's even telling you that I need 5 people to work on this particular aspect, they have to be paid at so much, this is what they have to give, and so on and so forth. Lots of interesting information. Take a look at this. Intricate information on how this temple should be built. So this, when I saw it, blew me away. Because I said, till then, I was under the impression that, all right, engineering came to us once the Europeans came here, and it's only after that we were using mathematics and building these huge buildings. This is a revelation. that there was actually, in this case, we have the palm leaves. We don't have the palm leaves in many other places, so we don't even know how they were built. If you go to Brihadishwara, there's epigraphy that says who built it, but doesn't say how it was built. In Konark, we are lucky that there actually are palm leaves that detail the entire construction process. So amazing, amazing piece of work. Very brief on metallurgy. Metallurgy finds mentioned Rig Veda, Thruva Veda from earlier than 3000 BCE, copper, bronze, iron, wood, steel, gold, silver, and zinc. We have archaeological artifacts from 2300. Here's, for example, copper plate, which could have been a prototype for a printing block in addition, knives, and the famous pillar over here, and so on. So what I've done over here is I started out the series with showing you lovely pictures of Indian engineering heritage. From that, I'm jumping to selected profiles for Indian mathematical heritage. The Sulba Sutras, these form perhaps some of the earliest works next to the Rig Veda. The Rig Veda itself has got an enumeration of the numbers, it's got an enumeration of powers of numbers, and so on and so forth, basic operations of mathematics. But Sulba Sutra is one of the 6 disciplines of Vedanga, an appendix to Yajurveda. Major Sulba Sutras are credited to Apastamba, Baudhayana, Manava, and Katyayana. The mathematics over here has got right angle triangles, geometry, square roots, and numerals, concept of zero from Paninian rules. Shatapatha Brahmana shows all of this knowledge in the construction of altars and so on. And therefore, the Sulba Sutras are probably dated to earlier than 3000 BCE, because later on I'll show you how the Shatapatha Brahmana can be dated to that kind of a time interval. So this knowledge was transferred to West Asia around 1800 BC following migrations after the drying up of Saraswati, as well as a 200-year monsoon hiatus that we had. We'll talk about this a little later. So here is the square root of 2 as discussed in Sulba Sutra. This is critically important for us because this forms a battleground with Professor Otto Neubauer, who says that Indians got their knowledge of mathematics from Babylon based upon certain ideas. We'll talk about that a little later. And it was based upon this tablet over here, which is in the Yale University collection, the Babylon cuneiform tablet over here. It seemed to show in base 60 system how to calculate the square root of 2. Sulba Sutra in this verse and this thing tells you exactly how this calculation should be done. It can be shown to be based on successive approximation by averaging, and it comes out to be the same square root of 2 as over here. Very, very interesting over here. So the question comes, who borrowed from whom? Or did they borrow at all? The base is obviously different, and Otto Neubauer seems to think that it was Babylonian, and we'll try to see why those ideas were. Surya Siddhanta is an amazing text. We don't know the provenance of that. We don't know when it was written, but there are statements that say that maybe Aryabhata's time. But Indian works always built upon a core body of work that is written by somebody else, layered upon by somebody else, layered upon by somebody else. So by the time it comes to Aryabhata, we know there are pretty ancient sections as well as recent sections. So this one has got chapters that talk about all these things here. I'm not going to read it, but very, very, very modern looking knowledge systems that you can see over here that talks about astronomy as well as mathematics. There are also time measurements in Surya Siddhanta, which if you take the second, if you map it to our well-known second as 1, you can see that they go to powers of the second up to a cycle of Brahma 10 to the power of 22, all the way to 10 to the power of -7. I still don't know why Indians would have had a need to measure time to 10 to the power of -7. It's enormously short interval. I don't even know what would have been there to measure such a passage of time, but it is there. A very, very brief history of numbers. Indians, we know, invented decimal numbers at least 2000 years ago. It was adopted by Arabs in 9th century. There was a book by Al-Khwarizmi on calculation of Hindu numbers, and a book by Al-Kindi on the use of Hindu numbers. And this diffused to Spain in 976. There were 3 monks who wrote about this. And there's a Gerbert of Aurelic who wrote a book on multiplication and division. He became the Pope later, Pope Sylvester II, and used abacus based on Hindu numerals. And Fibonacci. In Fibonacci's book, in the margins, you can see there's a translation from Latin, rather Roman numerals to the Indian numerals. So that showed the mapping on how this was to be done. So he introduced the Hindu number 0 decimal place in 12th century, but even then Europe did not adopt it because the church believed that anything coming from the Muslims or others were works of Satan and you should not take those works. So although these ideas were introduced, they still use Roman numbers and so on until about the 15th century, 1522, when this German, he explained how to use positional arithmetic and decimal use for the calculators or the mechanics and others, how to use these numbers. Once he did that, then there was widespread replacement of Roman numerals in the 16th century. So this is the background of how they started using Indian numbers. Some recommended reading, there's The Origin of Mathematics by Seidenberg, and this book by Guy Verghese Joseph, as well as this book by Irfa. And obviously, not put it here, but the works by C.K. Raju also all give a pretty good perspective on these things. Some of the greats on Indian astronomy, I don't have to read these, I've already done this in the past. So this is Brahmagupta, who did some enormously interesting works. He studied earlier works, proposed solutions of linear, quadratic, indeterminate equations, sum of squares and cubes, rules for zero operation, negative, positive numbers, theorems in geometry, trigonometry, interpolation, astronomy, quadratics, amazing amounts of works by this gentleman. Bhaskara I, he wrote on the zero, positional arithmetic, and the approximation for the sine function in addition. This approximation for sine function is very, very accurate. Even today, you could substitute it in your algebra equations if you didn't want to use this transcendental function. Bhaskara II, he wrote Siddhanta Shiromani. He also estimated the precision of equinox with an amazing number over here. We'll talk about this a little later. He had elements of differential calculus also. So amazing continuation of works by Indic people. Madhava of Sangama Grama in Thrissur. All of these expressions you see here were done by him. They were all infinite series, and he proposed how these infinite series can be expressed, and this is his work. So he's the founder of the Kerala School of Astronomy and Math, worked on infinite series, calculus, trigonometry, algebra, iterative solution of nonlinear equations, and Guy Verghese says his mathematics was transmitted to Europe a century before Newton by the church, and a lot of others following him. Yuktibhasha. This is one of the books that is in the news these days because this is written by somebody called Jeshtadeva, who was in the same school of Madhava. He wrote a Malayalam compendium of works of Madhava, Nilakanta Somayaji, Parameshwara, and Jeshtadeva, and Achyuta Pisharati, all these people. Seems to have foundation of calculus, predates Gregory and Newton, contains astronomy, mathematics of infinite series, integral solutions, series expansion, integration, differentiation. Amazingly modern pieces of work before the Europeans had a clue about doing these things, more than 100 to 200 years before that. The European line is that there's a person called Vesh who in 1832 published a paper on Yuktibhasha, long after Newton and so on. However, Indic authors like Guy Verghese and others state that these works are transmitted much earlier to the church via the church and trade also. I'd like to very quickly go through the astronomical heritage of Hindus. Very ancient knowledge is encoded the metaphor of stories. So if you go to very ancient works and look for mathematical astronomy, you're not going to find it. You're going to find stories. And the uncoding of the stories is what contains information. You learn from that. Later periods saw mathematical treatment of astronomy. This is a Siddhantic period. We'll talk about that just a little bit. So we know that there are star trails. If you look at the northern hemisphere, look to the north skies, you have Dhruva over here. If you keep a camera open in the evening, you'll soon get these star trails that you see over here. And the earliest astronomy is encoded as stories in Vedic literature. We have a story that the Saptarishis encircle Dhruva. Everybody knows the story, right? We are told that Saptarishis go around Dhruva, and that really recounts this knowledge of this information. So the early Indians in the Rig Vedic period already had knowledge of the rotation of the earth of this nature. Early Indians also had a clear idea of the equinox and solstice. In your house, if you have an east-facing window, you look at where the extremal rays of the sun come at 8 o'clock in the morning and make a chalk mark over there, wherever the extremal ray is. Every week, 1 week later at 8 o'clock, make a mark again. Next week, 8 o'clock, make a mark again. Pretty soon you'll find that the sun's extremal rays go from north all the way to the south for 6 months. Then the ray retraces back and goes back to the north for 6 months. So using no more technology than a 6-year-old child with a chalk mark, you can trace out over a period of a year what is the extremal solstice point in the north and the south. You could figure out both of these things. You could also figure out the duration of the solar year. Knowing how much time it takes from here to here, could figure out what is the solar year. You could figure out the equinox position. You could figure out the solstice positions. So our Indians were very, very conversant with these things. Uttarayana, Dakshinayana is mentioned even in the Puranas. They could figure out the length of the solar year. They could figure out that we need to add an Adhikamasa in Rigvedic times itself, that to synchronize between the lunar calendar and the solar calendar, they knew we needed to add a Adhikamasa right in the Rigvedic period. So very, very ancient logic we're talking about. We need to talk about precision, because precision is a critically important phenomenon for us to understand. The Earth, in addition to rotating about its axis and pointing the northern hemisphere to Polaris, it is also tracing a slow path in the sky. What is tracing? The axis of rotation, where it is pointing to. Now we're pointing to Dhruva. Where it is pointing to traces a slow path that takes 26,000 years to complete. And that is the precession cycle. Because of the precession cycle, where we are pointing changes. Today we are pointing at Polaris, but when Yajnavalkya wrote Shatapatha Brahmana, we're pointing at Thuban. Thuban was a pole star. There was a period of time when Abhijit was a pole star, Brahma Rishi, and that is Vega. So precision does this to us. Vrittagarga had already estimated the precession rate at 36,000 years. Vrittagarga, approximately 500 BCE or earlier, he had already estimated this at that time. Bhaskara II, who lived in the 10th century, 11th century, he had estimated this to 25,461 years. Amazing prowess by ancient Indians to have done something like this. So the Indian astronomical model was one of nakshatras and Rashi. I've talked about this in earlier talks too, so I'm not going to spend too much time on this. Bottom line, it was a division of the sky in 13 1/3 degree segments, 27 of them. They also divided the sky in 30-degree segments, the 12 Rashis. And they also had a concept of month. If the full moon appeared over the Chitra nakshatra, that month was referred to as a Chaitra Masa. So Indians in some parts of the country use a full moon as a marker. In some other parts of the country, they use a new moon as a marker. So Amanta month or the Purni Amanta month. In different calendar systems, you have these things. So they had a concept of nakshatra of the day. They had a concept of a month, lunar month. They had a concept of a solar year. And they were able to now use that knowledge to evolve enormous mathematics to do yugas and other such things. We will see that very, very presently. So here is a listing of the nakshatras in two of our ancient books, the Vedanga Jyotisha, Surya Siddhanta, and the principal star, which is aligned with these things. So this mapping came about when the British came to India, and they asked the Pandits, what is that nakshatra? They'd say what the nakshatra is, and the Pandits and the British should map it to their Western systems. That's why today we have a mapping of this nature. If you're wondering how old is the nakshatra model, well, at least as old as Atharva Veda. Atharva Veda in this particular reference, if you use a Griffith translation, you see I've highlighted some names here. It's talking all over the place over different nakshatra names over here. So at least as old as Atharva Veda, we know that the nakshatra model is that ancient. Ancient Indians also noted something called the synodic and the sidereal months. So from new moon to new moon, it takes 29.5 days, and that's referred to as a synodic month. However, if you go from the nakshatra, if you start at Chitra nakshatra and you want to see how long it takes to come back to that nakshatra, that takes 27.3 days. So there's a difference. There's a difference between these two, full moon to full moon or from backdrop of the skies. Indians knew about these things and they wanted to reconcile between these two cycles in the observed solar year. That gave rise to several insights, the Adhikamasa, the different yugas, the great cycles. We had the 5-year cycle, we had the 19-year cycle, the Samvatsara cycle, 60-year cycle of Jupiter and Saturn, all the way to the Chaturyuga cycles. All of these were outcomes of intellectual expression, trying to make sense of the movement of the heavenly bodies and those kinds of things. So Indians use their brains to try and understand this phenomenon, make sense out of this. That's what gave rise to all of these things. So today we know that we mark the passage of time using the Panchanga. Panchanga is a multi-dimensional measurement. Typically we use a Muhurta, which is a 1/30th of a day or a 48-minute interval, in which you make reference to Nakshatra, Tithi, Vara, Yoga and Karana. So these are the 5-dimensional measurements of time which Indians use traditionally, and even today traditional Indians make use of this kind of a measurement of time. I'm not sure you can see this from back there, but I thought I'll very, very quickly give you a brief background on Indian astronomy. When ancient Indians saw the sky, what did they see? So this is today's night sky in New Delhi. So this is the horizon, and this is the west direction, north and east. And this is Polaris. This circle is a precession circle that I talked to you about, and here is Abhijit. And whenever Indians talked about nakshatra for the day, it was always in relation to when the moon appears over the eastern horizon, what nakshatra is it in? What section of the sky is it in? So today, when the moon appears in the eastern horizon, I'm not sure of the time, I can't even read it here, I'm not going to make a guess. But when it appears on the eastern horizon, it appears to be in the Rohini nakshatra. This is Rohini nakshatra. So today's nakshatra would be Rohini because when the moon appears, that's where it is. So in addition to that, you see these circles over here. These circles are projections of Earth's latitudes and longitudes in the sky. So they become celestial coordinates. So this is the celestial North Pole, 90 degrees, 80, 70, 60, 50, 40, 30, 20, 10 and 0. So 0 is the celestial equator. On the day of the equinox, the sun would be exactly on the celestial equator. Okay, so the Uttarayana is 6 months of a northward course of the sun. So it goes up to 23.3 degrees north. Then the sun retraces, crosses the equinox and goes minus 23.3 degrees to the south. Indians knew all these things. So these were the cardinal positions. So they could look at the sky and figure out the extremal points, where it should come and what is the nakshatra against which a certain solstice or an equinox would appear. And they recorded these things. They recorded these things in many, many of our texts. Based on that, we can have an understanding of how ancient these things are. One big example is the Vedanga Jyotisha. Vedanga Jyotisha, there's got two components, Rig Vedanga Jyotisha and the Yajur Vedanga Jyotisha, and they've got these verses 5 and 6 and 6 and 7. These verses say there was a winter solstice in the Dhanishta Nakshatra. So the colonial Indologists tried to make sense out of this winter solstice, the Dhanishta Nakshatra, and they cranked back because of precision. That's no longer a true statement. When winter solstice happens, we are not at Dhanishta Nakshatra. It happened in the past. So they cranked back in time and tried to figure out when did that happen. And various scholars gave various times, but the closest was Colebrook and Dikshit, who came to 1400 BCE. And it turns out that I simulated this in the calendar and planetarium software. Winter solstice happens here when the sun reaches 24 degrees approximately over here to the south, and here is Dhanishta. So this clearly shows 1440 BCE would be the date for Vedanga Jyotisha. Why is that important? It's important because you can use this to debunk some of the things that Max Muller did. Max Muller had used a linguistic model and tried to say that the Chandas period is one, the Mantra period is one, the Sutra period is one. He crammed all these things from 1200 BCE to around 200 BCE. And he said that the Jyotishas are the last Sutra period composed between 600, not in 600, maybe 300 BCE to 200 BCE. But then the Vedanga Jyotisha seems to have been written in 1440 BC. So this was a huge hit to him towards the end of his career when people criticized him saying, what about this? You're talking about a particular date for the Vedanga Jyotisha, but the astronomy inside says 1440 BCE. This led to certain things in predictable ways. I'll talk about that a little later. Shatapatha Brahmana, Yajnavalkya, has got a statement that Kritika never swerves from the east. I'm not going to go into details of all of these things, why it was so, but you have a heliacal rising of the Kritika Nakshatra, and this would have happened on an equinox point, and this equinox point is a circle, and what you see is that this particular date works out to 2982 BCE. Again, it's an affirmation of the antiquity of a Brahmana period. Again, it goes back and hits against Max Muller's dating, who said that Brahmana period is 800 BC and so on. You have a pretty ancient data encoded inside Shatapatha Brahmana. We have an ancient epoch encoded in tables. I'm not going to read all of these things, but many of the Puranas, temple epigraphy, and books like Surya Siddhanta and others seem to be referring to an epoch that is pretty ancient. So this Lee Gentle, who came to India, he's a Frenchman who came to Pondicherry. He got some tables from the Brahmins and published it as tables of Trivellur. He sent it off to his friend Cassini in Italy to analyze that, and Cassini came back and said that it refers to an epoch that is midnight of February 18th, 3102 BCE. So all of these things are referring to that particular epoch, and that turns out to be a rare conjunction of planets, sun, moon in the Revati Nakshatra. And some people refer to this as the start of the Kali Yuga and also an attempt to do a dating for the Mahabharata. I know there are multiple opinions on this, but this is one of the dates for that. So simulating this in the planetarium software, say February 1831-02, here is Revati Nakshatra. This is the ecliptic on which all the heavenly bodies go. And you find Jupiter, you find Venus, Moon, you find the Sun, you find Saturn, you find Mercury and Mars. All of them are clustered in the Revati Nakshatra. A very, very powerful affirmation that there's a Vedantic concept in an epoch of time in which the so-called Aryans shouldn't even be in India because they are supposed to come only in 1500 BCE. Very, very powerful statement. I'd like to talk to you about Aditi, who is the mother of the gods. Aditi with Kashyapa gave rise to Adityas, Rudras, Vasus, and they're supposed to be the Devas and the Daityas. Bhagavad Gita talks about the 6-month course of Uttarayana, which is the path of the Devas, and then the path of the Daityas, which is Dakshinayana. And we get the impression that the mother should be equidistant from her sons, whether it is Devas or Daityas, she's got to be equidistant. So you get the feeling that there's something to do with an equinox and Aditi over here. If you're thinking that, you're right, because that's what happens. Now for Nakshatra Punarvashu, the deity is Aditi. I'm not going to go into great details of why that is, but Balagangadhar Tilak as well as Abhyankar called this out and said that the era of Aditi is 6000 BCE. It refers to the vernal equinox at Punarvashu Nakshatra. And you find that the vernal equinox position is over here, and the nakshatra at that time is Punarvashu. If you simulate this in the planetarium software, it comes to 6000 BCE. So this is the era that Abhyankar and Balagangadhar Tilak referred to as the era of Aditi. There's one more interesting data point with Ashwinis. Ashwinis are there all over the place. We know about the story of Sun, that he married Sanjana, and they had twins, the Ashwinis, and Sanjana couldn't take the heat, so she decided to run away from the sun, as far away as she could get from the sun to be cool. If Sun was in the winter solstice, Sanjana is in the summer solstice point. If Sun was there, she's as far away from the sun as possible. She did that because she wanted to go to the cooler region. She left the shadow Chaya and left. And you find that there are a lot of mentions of Ashwinis in the Rig Veda, a lot of verses over here. Our ancients did not just say these stories because they loved to say stories. They were encoding astronomical information in some of these stories. So this particular episode, along with this information of Ashwinis, is interpreted by Tilak and Abhyankar as a heliacal rising of Ashwini Nakshatra. Because all over the Rig Veda, you find verses like Ashwinis appear at dawn for their share of sacrifice. Okay, Ashwinis appear at dawn for their share of sacrifice. Based upon that information, you see the heliacal rising of Ashwini, winter solstice, because in the northern hemisphere, that's when it's cooler, because that's when Sanjana has fled from the sun and so on. And this turns out to be 7200 BCE, very, very early time frame in the Rig Vedic period. And there are a whole lot of ancient observations. I'm not going to read these things. P.V. Vartak has got about the seasons, the Rig Veda, and various other texts, Puranas, and so on. A whole lot of dates over there. So what I've done so far is try to emphasize to you that many of our ancient texts are encoding early information as stories. So these stories are there in the Rig Vedas, in the Brahmanas, and other places. If you do not know the key to unlocking that wisdom, it's a silly mythological story for you, which makes no sense. But if you knew what the significance was, you suddenly see they're encoding dates, they're encoding information, and so on. I refer you to a talk of mine, TED Talk, where I talk about some of these things, how information is encoded in stories. So Siddhantic astronomy is a particular phase when Indian astronomy went from encoding stories as metaphors and so on into using mathematics to understand the course of the heavenly bodies and so on. We know that there were many early Siddhantic works that are lost. The Surya Siddhanta talks about these things, but it also says those works are no longer available. Even the author of the Surya Siddhanta is referring to such an ancient epoch, saying that those works are not available anymore. That's what you see over here. So the texts are lost, but the citations remain. This shows a gradual development of mathematical astronomy in the ancient past. It's very, very important because all of a sudden you have Aryabhatta there with an enormously developed mathematics, leading us to critique that Maybe Aryabhatta got his knowledge from the Greeks and so on. This is the critique that comes out against us. But then when you look at the antiquity of some of these works over here, it's clear that there's a gradual development of mathematics. I'm not going to read all these things. There's a deep tradition of mathematical astronomy, whether you look at Vedanga Jyotisha, Surya Siddhanta, Vashishta Siddhanta, Paitamaha, Romaka Pulisa Siddhanta, Aryabhatta's work, Varahamira's commentaries on the five Siddhantas, Mahabhaskariya, Siddhanta Shiromani, and Nilakanta Somayaji's work, Yukti Bhasha, and Siddhanta Darpana that we talked about. A lot of information that there's a tradition of knowledge in India, a slow growth accumulation of knowledge rather than a borrowing of knowledge from outside. Till such point, when we came to Nilakanta Somayaji, he already had a partial heliocentric model. He had a model in which he thought the earth is stationary, the sun is going around the earth, and all the planets are going around the sun. So he said that Venus, Mars, Saturn, Jupiter all go around the sun, and the sun along with all these things goes around the earth. And the same model was used by Tycho Brahe in Europe. So you see, there's a transmission of ideas from one place to another, giving rise to a continuity of thought. Well, there was an early attempt to discredit Indian astronomy because, like I said, Max Muller had come with a certain linguistic model and dated some of the Vedas to certain periods of time. And it turned out that somebody came and confronted him and said that, Vedanga Jyotisha is 1440 BCE. Rig Veda seems to have Aditi's episode and Ashwini's episode, Balagangadhar Tilak. He called out those criticisms. Confronted with all these things, Max Muller finally, in this book, he writes a foreword, very fiercely defends his position, and he says he can accept only Colebrooke's date because 1400 BCE is after Aryan invasion of 1500 BCE, and others, he says, Hindu astronomy is unreliable. Same thing with this gentleman over here, John Bentley, says that Hindu astronomy is unreliable. And these kind of views are loosely flaunted to the present times by Indic scholars. I have talked to professors who are living today who you'd normally think are Indic scholars, but even they have espoused views like this, saying that Indic astronomy is unreliable. I think you can make such statements only if you had no idea about Indic astronomy, then you would make these kind of silly statements. I talked earlier about Otto Neugebauer. He is a very powerful man who set the stage for how Western world views Indian astronomy, Indian mathematics, and so on. This is a book that he wrote, Exact Sciences in Antiquity. So his claims were the length of longest to shortest day is 3:2 in both Hindu and Babylonian astronomy. Starts on page number 162. He makes a claim. So he starts seeing parallels in Babylonia as well as in Indian astronomy. He says Varamihira, as well as Lee Gentle, who saw how the Tamil astronomers were using calculations to make duration of eclipse, when the eclipse will start and so on. He encoded this algorithm. They actually went through a process of half an hour of calculation using shells and so on. So he made a note of all their calculations and sent it off, and based upon that, he's saying they use something called linear function to compute the moon's motion. That's what the Tamil astronomers were doing. After half an hour of calculation, they said the eclipse will start at this time, eclipse will get over at this time, this is the duration of the eclipse. All that, he said, is exactly the same as what was done in Babylon. In page number 165, he makes this claim, something called a zigzag linear function. The terminology as well as the zodiac name, he says, matches Babylonia. Varamihira, he says, incorrectly copied constants of planets from Babylon. And he concludes that Indians copied astronomy from Greeks and Babylonians. Now, I strongly urge people to read Subhash Kak's work on Babylonian and Indian astronomy, early connections, where he makes a powerful rebuttal of all of these ideas. So please do read this particular work. I'm not going to go into details. His student was Pingree. So Pingree was Otto Neugebauer's student, and he mistranslated a Nepali copy of this Yagnaveshwara's Yavana Jataka, and he continued claims of his teacher in Indian astronomy that we incorrectly borrowed from the Greeks and Babylonians, the ratio of 3:2, use of linear functions, use of water clock, concept of Tithi, use of 2 intercalary months, that is every 5 years it synchronizes, concept of 5-year yuga. Once again, refer you to Subhash Kak, who does a concise rebuttal of these things. Also, K.S. Shukla. Shukla has also basically debunked some of these works that he did. as well as Bill Mark. He's also recently come out with works that says Pingree fabricated findings, misread and conjectured to arrive at conclusions. Very, very strong statements from both Bill Mark as well as Shukla that Pingree had made incorrect understandings of Yavana Jataka and the translations of those things. Anyway, these are the received wisdom that we have today. Nobody questions Pingree and nobody questions Otto Neubauer. So whenever you see works that claim that Indians got knowledge from the Greeks or the Babylonians, you should understand that they are using Neubauer's works as well as Pingree's works. This lady is the student of Pingree. So it's a 3-generation parampara now. So she's Kim Lofker. So she critiques Subhash Kak's astronomical code of Rig Veda. She subscribes to the Aryan invasion theory. This book on mathematics in India, in page 6 to 8, she says that she's leaning towards the Aryan invasion theory. If you subscribe to Aryan invasion theory, you have some constraints put on your thinking. You cannot go outside those constraints. Those constraints will require you to assume knowledge came into India from outside. So once she does that, she also appears to be open to the Babylonian transmission issue, whether it came from India or Babylon. She appears to be open to that. She discards the idea that Kerala school influenced Europe. In these pages, she says that there's no influence of Kerala on European mathematics. Again, that's based upon certain assumptions that wish and other such things. On the whole, she's got a refreshing book, but it's got a strong Eurocentric subtext, and you need to be careful reading that. She reconstructs Parameshwara's expansion of the sine function and shows because of the factor of 4 instead of 6, she says it was a crude approximation rather than understanding Taylor's series. Taylor's series is a mathematical entity where you take a nonlinear function, you can expand it as an infinite series. This is the basis of all of our today's technological works. It's the basis of that. Once you have a linear function, then you can start doing predictions and things like that. And it appears that Indian mathematicians from the Kerala School of Math had up to 3 terms of the Taylor series. Taylor series is the later term that came, but then up to 3 terms. Because a factor 4 was used instead of 6, she says it was not based on understanding but by a crude approximation, and she shows how that approximation was got. In other words, she's working just like Pingree and just like Otto Neubauer to show that Indians got knowledge from Babylonians and Greeks. So they had to labor very hard to go against the flow because there's overwhelming evidence from this side that says that Indian knowledge went to Babylonians and the Greeks. So that is what it is. Conclusions. Initially, astronomical knowledge is encoded as stories. Later, Siddhantic astronomy saw a strong development of mathematics. We have a long trajectory of knowledge from earliest works of Patani Samanta. Mathematics, partial heliocentric model was the heights of accomplishment. Astronomy learning was greatly impeded by Muslim invasions once Ujjain was destroyed and so on and so forth. Many of the knowledge systems are gone. Eurocentric attacks on Indian math and astronomy from colonial to present times are dictated by deference to the Aryan invasion theory model. So if you debunk the Aryan invasion theory model, all these constraints fall. None of these assumptions are true anymore. The field is open to fresh interpretation and other things. We're talking about the medical heritage of ancient India. I'll show you that we had the most ancient medical systems in the world, impacting every civilization of the world. So, in the hermeneutics of Ayurveda, Surendranath Dasgupta, he says medicine was the most important of physical sciences. It was intimately connected with Samkhya and Vaisheshika physics. It's the origin of logical statements encoded in Nyaya Sutra. Everything needs a killer application, right? Once you have a killer application, then your thinking is very clear. And he says medicine was that killer application. In order to diagnose what a person has, you must logically go, could it be this, could it be that, could it be this, could it be that, and that kind of a thing. So he said it's the origin of logical statements. So we're not going to talk about this very much over here. Atharva Veda and Ayurveda. So basically wanted to show that Indian thinking always existed in cooperation with the philosophy of the land. There was no break between this is science, this is philosophy. Everything was entwined with each other. So how was disease and ill health seen? Disease and ill health was seen due to unwholesome diet, which required Ayurveda to cure. Or if you look at the psychological aspects, due to your karma phala and transgressions. That's why you have a certain condition, maybe mental condition or something else. It required Prayaschitta and Atharva Veda practice rituals and other such things to cure. So in other words, it's a very neat understanding of both the physical aspect as well as the mental aspect and these kinds of things. Shishruta, we all know, he wrote Shishruta Samhita, 120 chapters in 5 sections, plus 66 later interpolations into this. He discusses a whole lot of subjects, as you can see over here, describes 1120 diseases, describes the human anatomy, how many bones, muscles, veins, and so on, describes surgical methods. I'm not going to read these things. And he also describes 121 surgical instruments. So that is the enormous scientific encoding in this compendium that he did, Shishruta Samhita. Here's an example of the palm leaf Shishruta Samhita. This is from the LA County Museum. It's a 12th century work in Nepal. That's how these works survived. And until such time it was committed down to the modern book and other such things, they were written in palm leaves like this. So here are some of the surgical instruments that is there in Shishruta Samhita. And you can take a look at this and say, whoa, it looks like these look like modern instruments over here. But then this is used by Indians at a very ancient time for all kinds of operations. He also used a cadaver. Today we think that dissection and other things came from the West, and they're the ones from Galen onwards, Roman times. Those are the people who did these things. But if you take a look in Shishruta Samhita, it says, cover a dead body with kusa grass, place it on the edge of the water of a rivulet. After 3 days, take it out and wipe out successive layers of epidermis and dermis of the muscles beneath by gently rubbing it over the soft brush. Thus, the smallest and thinnest arteries, which would have swelled and obtained a distinct extinction, are made palpable everywhere, even to the minutest details. In other words, he said how we can use a dead body to understand the internal working of the organs and things like that. This is there in Shishruta Samhita. Charaka Samhita. So these are all Western timelines over here. So it got its inspiration from Atharva Veda, which went to Punarvashu Atreya, the Bela Samhita, Agnivesa's work, then to Charaka Samhita, then to Dridbala. This is the citation trial for these works. Once again, 120 chapters and 8 sthanas. I'm not going to read these things. Very, very intricate knowledge of diseases and treatments and how we do various things. Very, very interesting. I'd like to talk to you about Boer manuscript. Boer manuscript is the earliest extant manuscript that we have of Indian medicine. This was found in Xinjiang province in 1890, birch-bark document, written in Prakrit, Gupta Brahmi script. It seems to be a subset of Charaka Samhita, refers to rishis Atreya, Harita, Parashara, Garga, Shishruta, Vashishta, and accepts the doshas, 3 doshas, Vata, Pitta, Kapha, but also talks Rakta dosha. This was translated by Rudolf Hornell in this particular work, and this is how it appears. So, Rudolf Hornell was a person who dated Shishruta to around 600 BCE. And how did he do that? He basically said the Jataka records that medicine was taught in Takshashila as well as in Kashi. So he places Shishruta to the east at Kashi and Charaka as a physician in the court of King Kanishka and Atreya as a contemporary of Shishruta in Takshila. So one person he places here, other person he places over here. Then he places Yajnavalkya, author of Shatapatha Brahmana, the court of King Janaka of Vaidehi, and is a contemporary of Ajatashatru. Then he uses Weber's work to place Yajnavalkya to 500 BCE. Why is that important? Because he says Shatapatha Brahmana seems to be aware of the bones described in Shishruta and not the bones in Atreya. So based on intricate understanding of the bone structure, he makes certain claims that Shatapatha Brahmana seems to have knowledge of the bones of Shishruta. Because of that, he says, Yajnavalkya is dated to 500 BCE, therefore 100 years before him I'll place Shishruta and give 600 BCE, as arbitrary as that. But we can go and see if there's any other way we can date Shatapatha Brahmana. Shatapatha Brahmana was deciphered in 1893 by both Dikshit as well as Balagangadhar Tilak. We already talked about this. And basically they used Kritika, and they tried to say the Kritika would have a heliacal rising in 2982 BCE. You can't understand this picture over here because this is talking about precision. So 2982 BC, we don't have a pole star. This is our pole star. In the current time, this would be at the center over here. But this is how much in the past we would have moved. So Kritika in 2982 BCE was on the celestial equator. Today it is somewhere over here because of precision. So we know that Shatapatha Brahmana should be dated to 2982 BCE, and because of that, Shatapatha Brahmana that mentions this Kritika phenomenon is in this date, And based upon knowledge of bones, Shushruta and Punarusha Atreya should also be before 2982 BCE and Charaka after this. So bottom line, we are using the same methods of Rudolf Hornell to date Shushruta, and Shushruta's lower bound comes to at least 2982 BCE. So I have a combined section over here for all the knowledge systems to talk about knowledge transfer. So very quickly talk about knowledge transfer. We know that there was ancient climate change approximately in 2000 BCE. If you look at this Nature paper, 2014, 200-year drought doomed the Indus Valley civilization. A genetics paper that says empty DNA from Bronze Age suggests a link between Indian subcontinent and Mesopotamian cradle of civilization. This paper came out just in July of 2019 that says a zebu was found in Mitanni and Hittite lands, and it talks about how there was a migration from the Indus Valley area 4.2 thousand years ago, and that had the presence of zebu cattle in the Mitanni lands. So we know that approximately 4,000 years ago, there was huge migrations out of India to places where water was in the Euphrates, Tigris, and those kind of areas. Isn't it amazing that if you look at Egyptian medicine or Hittites or anything, they don't have any evidence of any knowledge until after 1800 and 1500 BCE. Their earliest medical texts, the Smith Papyrus, Ebers Papyrus, and the Kahun Papyrus, all of these things are only after 1800 BCE. After the migrations have taken place, that is when you see evidence of these. There are contents of magic, trauma, surgery, gynecology, and gynecology, surgery, magic. All these things were contents of Atharva Veda. All of these things were contents of early Ayurvedic works. And these things seem to be injected over here. And there's a book over here that talks about antiquity of Hindu medicine that says plants and materials from India were in use in Egypt. And he hints at knowledge transfer from India. So this is an example of how Indian medical knowledge is transmitted to Egypt in this early time frame. If you look at the Mitannis, Hittites, and Kassites, the Mitannis invoked Indra, Varuna, and Ashwinis in their peace treaties with the Egyptian pharaohs. So when Egyptian pharaoh Amenhotep fell ill, the Mitanni king sent a healing statue of Shauka. Shauka is like Durga on a lion. So same thing is sent as a healing statue for him. And there is that evidence out there. Hittites suffered through 20 years smallpox, and they had a deity called Kamru Sepa, who was linked with Varuna. And she's supposed to trap the diseased demon in a bronze pot and save lives. If you're in a place where there's a lot of infection due to smallpox, you're interested in knowing how to be antiseptic, how to have good water. We know that if you store water in a copper pot overnight, it's got some antiseptic properties. So it recounts an idea that trap the diseased demon in a bronze pot and save lives. Very, very interesting. If you look at Babylon Akkadian medical text 1800 BCE, it talks about rational examination, looking familiar, right? Rational examination came from Nyaya and other things, looking on how to diagnose and so on. Logic therapy uses exorcism to cure illness due to curses. The Kassite medical letter from Nippur, that also talks about the same thing based on herbal medicine and spells. So very clearly, Mitannis, Hittites, Kassites have been exposed to Ayurveda and Indic knowledge systems. We should not go and see a direct, maybe a clay tablet saying we got it from India. There's no such concept in those days. There's no concept of visa, no concept of foreigners. People come, live, give an idea, and people start using those things. So we see echoes of Indian thought in early periods of time. That is what we are looking for over here. Transmission to the Greeks and Romans, very clear. If you look at Ayurveda, it talks about the doshas, all the doshas over here. Maps very clean to Hippocrates' model of this yellow bile and black bile and phlegm and blood and hot, dry, cold, wet. Maps to this very, very well. So Hippocrates proposed a system expanded by Galen later. If you see who was Hippocrates, he was a student of Democritus. Democritus was somebody who seems to have intimate knowledge of Vaisheshika Sutra. We had talked about this earlier. Read Subhash Kak's work. You'll find a lot of these kind of things. Also, there were Buddhist transmissions from 5th to 4th century BCE. Indo-Greek contacts from Alexander onwards, 330 BCE. We know, this is a mistake, it's not Alexander's uncle, but we know that Alexander ordered translation of works for Aristotle. We know Library of Alexandria set up in Egypt for transmission of east to west knowledge. All of these things we know were sources how the Greeks could get information like this. J.F. Royal also shows materia medica of Greeks, Romans borrowed from India, and that was a core of the spice trade. We had said that they came to Western India for spices, pepper, and these kind of things. What they don't tell you was Western India was the pharmacy of the world. If you think why today Kottakalaya Vaidishala and all those places make Shavanaprasha and all these kind of medicines, even in the early days they made medicines that was the drugs for the entire world. So that is a core of these transmissions. This is the places in Western India from where trade would take place, from here going on to Greece and so on. Transmission in the medieval period also we have works. Dioscorides, I think I'm pronouncing it right. He was a physician's 50 to 70 current era. He wrote a 5-volume Materia Medica with large number of Indian herbs, recipe for drugs. This was used for 16 centuries in Europe as a medical manual. Spice, herbs, medicinal drugs, all of these things ended when the Christianization of Rome in 330 current era. As soon as Constantine adopted Christianity as a state religion, the trade with India stopped almost overnight and they went into dark ages. Not only dark ages, they went through illiteracy and they also went through disease. Disease took hold of them. Why? Because they were no longer getting drugs from India. They were no longer getting spices from India. They were no longer getting the materia medica from India to cure their problems. So you see, Europe suffered a lot of diseases after that time frame. The Byzantine emperor, he persecuted the Nestorians and they fled to Kerala. These are the Syrian Christians who started around 500 current era. We are told that they came with St. Thomas. I don't think there's any evidence for that. The evidence says that they were Nestorians who came to India and they were the source of transmission to Syria because they had links with Edessa, the bishop at Edessa, and they had constant links with them all the time. And that formed trade links from all the way from Kerala to Syria. Nestorians and Greeks fled to Jandishapur in Persia in 530 current era, and that was a center for Indian medicine and learning. We know about Anushirwan, who sent his vizier, this Borziu, to India to get medical texts. And this is a picture in today's Tehran courthouse of this king, Anushirwan. Eastward also, we have a lot of information about eastward transmission of Indian medicine. We know Silk Route was used, Buddhist transmission route. The fact that Bohr manuscript was found in the Silk Route in Xinjiang province is an example of how Indian knowledge also was part of trade with the eastern parts and western parts of the world. Ideas of hot and cold, yin, yang, dhyana to zen, all those things are there. Fahian, who came to India, made several observations, similarly Bodhidharma, Shaolin, and Huensang, and Yixing, and others. And we also have a curious poem by somebody called Liu Yuxi, who says a Brahmin priest physician who bestowed eyes. This turns out to be Nagarjuna, who was a Buddhist actually, not a Brahmin, and he practiced cataract surgery from Shushruta Samhita, and he saved Chinese eyes. And she wrote a poem for him, and it survives to the present time that somebody bestowed eyes on them. So very, very amazing. So we know about these transmissions. Transmissions to Muslim lands, we know once Sindh fell to the Muslims, Manka, who went to the court of Harun al-Rashid, translated Shushruta Samhita, used by Ibn Sina, and these medical texts form the foundation of European medicine from 12th century onwards. We know about Al-Tabari, who wrote comparative works of Greek and Indian medicine, and this person, Allah ibn Ali, who translated Charaka Samhita to Persian. And all this knowledge was transmitted into Spain. All these were under Muslim control from Sindh onwards to Arabia, to North Algeria, to all these places up to southern Spain. So Indian knowledge was taken and injected over here. And we know about Al-Kindi, who translated many of these things and wrote works on mathematics, medicine, astronomy, and so on. In Toledo, we know that there were Christian monasteries whose only job was to translate from Arabic into Latin. And that formed the basis of many of the European works too. And that's how their corpus of knowledge also built. They used astronomy, they used translations on mathematics, on medicine, and this formed the corpus of their own works for the Renaissance and such things. Colonial period, I'm not even going to read this. A whole lot of people who took Indian knowledge. This person in Goa, he wrote this particular book on Ayurveda, translated to Latin by this particular Clusius. Botanist Hendrik van Reed, he came to Malabar and wrote this with the physician's help. Johann Koenig, he was a pupil of Carl Linnaeus, the very famous botanist. He was a source for Linnaeus' works on botany. He's described about the plants of India and so on. Bartholomew Ziegenberg, who collected many, many Tamil medical works and other such works, 1712. Here's a bibliography of all his works over here, and other people. So medical colleges in India, that was in Pondicherry, Madras, and Kolkata, they were teaching Ayurveda for the longest time because their own medicines did not cover what should be done. Their pharmacology was entirely making drugs out of Ayurvedic preparations. However, all that stopped in the late 1880s or so, after they had digested all of Indian medical knowledge and they had their own chemical processes in making drugs. So after that, the Western education system started. So conclusion from this section is that enormous antiquity for Indian medical knowledge, the roots in Atharva Veda, we talked about Sushruta and Charaka. Ayurvedic medicine was transferred to all parts of the ancient world, Egypt, Babylon, Greece, transferred to West Asia and Europe in medieval and colonial times. After digestion of this knowledge, the practice of Ayurvedic knowledge was discouraged. Today, scientists are rediscovering fundamental truths about body-mind effects for cure. So it's 303. I will very quickly talk about roots of music and we will stop after that. So typically when we hear about music, the received wisdom is music arose independently in various parts of the world. In India, in Greece, in China, in all these places, music independently arose. We'd like to examine some of these assertions and see how real is those things. We are told that music is universal language. However, it became a standard. And we had to ask, how is it that it was standardized? If it was universal and arose independently, we would expect variation in the way music is formed, but there's a standard that we see. So some questions: how did similarly spaced scales evolve in Indian and Western music? What accounts for commonality of instruments? We'll do a very, very brief investigation. So Indian music, we know that ancient period from the most ancient times to 12th century, medieval period 13th to 18th century, and the modern period. And there are several things to learn about when we talk about Indian music. Not going to go into all of these things. If you look at Chandogya Upanishad, it talks about division of the octave into 22 parts. 22 parts is something alien to most of us because we know about the 7-tone music, we know about the 12 semitone music, but 22 parts. So basically this is Sa, you have Re, Ga, Ma, Pa, Da, Ni, Sa. This is 7 notes over here. And here you have the semitones, the 12 semitones, and here are the 12 Shrutis. Now, each of these, remember in India, every knowledge system was deeply tied with the philosophy of the land. So music was also associated with divinities and swaras. That is the earliest way music was seen. If you look at the evolution of the scale, in the beginning, Samagana only used 3 notes as Uddata, Anudatta and Swarita. Later on, it evolved into the 7-tone music that we see here. Now, one important question is, what was the reference for Indian music? In other words, today if you get a musician to do some work for you, he's going to get a pitch pipe. That's what the Europeans use. A pitch pipe will tell you that this is the pitch of the A note, this is the pitch of the C note, pitch of something else. Today you have on your iPhones and phones, you've got a tonal generator that can tell you what the reference tones are. In ancient India, the reference tones were the sounds of these animals over here. So the sound of the heron was this ma, goat was ga, and bull was this re, and so on. So this was the reference notes that was told for Indians, because how do you communicate to somebody from north to the south that this is the sound of sa, this is the sound of re? It could be anything, right? So the reference notes were these things. So the relation between east and west, the 12 Shrutis are mapped to 12 semitones. I've shown this over here. In the European practice, the octaves divided into 12 semitones of exactly the same width. They use the concept of cents. So the entire octave is divided to 1,200 cents, and each division here is 100. C to C sharp is 100, C to D is 200, and so on and so forth. So that is a division of the scales seen in Western music. The tonal relation between Carnatic, Hindustani, and Western, we see that in Carnatic, these are the names, very similar names with slight differences in the Hindustani. Not going to read all these things. And here is the equivalent Western notes associated with these things. These are 12 semitones. Now we come to the interesting aspect. There appears to be transmission from Samaveda to the Greeks. And we see that the oldest form of Samavedic scale was pentatonic gamut, arrived at by quintal tuning. I will not go into great details about this, but in this particular work by this gentleman over here, Phadigon, he says that he talks about Pythagoras. And he says about Pythagoras how he lived at the same time as the Upanishads and the same time about these things. And he talks about Silva Sutras, and he says, by analogy, for the present, surmise that the minute study of musical intervals in India took place at the end of the Vedic period. That apart, the bottom line is there seems to be exposure of Pythagoras to not only the Upanishads, but also the Silva Sutras. So let's take a look at this. Pythagoras is seen as a father of Western music. So he evolved something called a Pythagorean scale. This Pythagorean scale is as F, C, G, D, A, E, B, derived from circle of fifth. This is a very, very musical terminology where you jump from one note to the fifth note. That will give you from F to C, the fifth note is G, fifth note is D, fifth note is A. This way you can the whole thing. Now if you put it in order from C, D, E, F, G, A, B, C, you'll get a pattern of the major scale is tone, tone, semitone, tone, 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 semitone. This is the same as, for example, Shankarabharanam tune in Raga in southern India. The same tone, tone, semitone, tone, 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 semitone, same pattern over there. So these are the notes in C major and in the sequence interval, like I said over here. So Pythagoras used the ratio of 3:2. What is more important, the number 3 was important for him. We know that in India, the number 3 has got very sacred meanings. He also used a 3:2 ratio. The 3:2 ratio is what gives you the circle of fifths to get the scales and other such things. So by doing that, that various other kinds of music, Ionian and I'm not going to go Lydian and all these things, you get that. So bottom line from C, you see G is the 3:2 ratio from C to G. From G to D would be a 3:2 ratio. From D to A would be a 3:2 ratio. That is the bottom line. I know it's very mathematical, but the bottom line is Pythagoras made use of ratios from the chord to do that. So if you look at the 7-note Lydian scale, same as the Kalyani Raga, you can, I'm not going to read all these things, but 3 whole notes, semitone, 2 more whole notes, and final semitone. If you look at the tonal frequencies of the Indian music system and the Western music system, it is very clear to me that these are related. It cannot have been an independent development and getting the same tonal frequency difference from each other. I'm not going to go into great details over here, but it's clear by studying these things, you figure out these. So we talked about Silva Sutras, we talked about how there's a lot of mathematics in Silva Sutras. And from Silva Sutras to Pythagoras. Pythagoras is known for his Pythagorean theorem. He believed in the idea of soul transmigration, what is today known as reincarnation, pure vegetarianism, no meats, beans or wine, and the constant working towards an attainment of bodily purification and purity to be able to interact with the divine, meaning universe. In other words, he's internalized Vedantic ideas greatly. Not only is he a vegetarian, he says your constant goal in life is to attain Brahman. So that is his thinking over here. He saw music as a wholly spiritual, scientific endeavor, which is exactly the same in India. In India, music did not start with Bollywood music. It started with Samaveda hymns. It started over there. That was the first part of music. Started with liturgical. It was holy. So he saw the same thing. So he promoted what became the basic fundamental idea of music theory, that by dividing the length of a string, that's very important, dividing the length of a string, ratios of halves, thirds, quarters, fifths, he can create the musical intervals. Now this is exactly the same as Silva Sutra. Silva Sutra, all of mathematics was a string. They take a string, divide it into ratios and teach how we can do ratios, how we can do mathematics and other such things. So Pythagoras came to India, studied Silva Sutra, studied all these mathematics, studied these ratios, and he seems to have taken exactly the same music into Western notation, and that became the foundation of Western music from there on. Of course, in India, we don't see harmonic music the way there is in the West. Today, you have harmonies over there. We don't see that, but we see a lot of melodic music in India with the raga system and so on. So Pythagoras, not going to read all these things. We already talked about how is a vegetarian, Gurukulam, and transmigration of souls. Interesting connections. Indian music, Silva Sutra, math with strings. Pythagoras used string ratio to define notes. Samaveda started with 3 notes. 3 is sacred for Pythagoras, 3/2 ratio starting with point for scale. He didn't use 1/2. He didn't use that kind of a thing. He used 3/2. That's very, very critical. Samaveda Swara system of 7 notes, diatonic music of 7 notes. From 22 Shrutis, we get 12 semitones and 7 swaras. From 12 semitones, 7 notes. Swaras are associated with divinities. Music used for Samaveda chants initially. He saw music as holy and spiritual. Even he did not say music is for entertainment. He started as a spiritual endeavor. And we have Saraswati as a patron of learning and music. And he actually erected a statue of Muses outside the library in where he lived, because that was a patron of music and learning. Just like Saraswati was patron for us, the Muses were divinities, female divinities, who were also for learning in Greek, the patron of learning and music. Very, very interesting connections. So, interesting question, which came first? The chicken and egg question. Did scales come first or did musical instruments come first? What came first? So, evolution of musical instruments. We see in Bhimbetka 12,000 years ago, we see evidence of dancing. Take a look at this figure over here. You see drumming and you see all these things. There's already some evidence of music over there. It's mentioned the Rig Veda. Rig Veda's got this nali similar to a flute, and the dundubi, which is a drum, and the veena and other such things are also mentioned. I'm not going to go into detail over here. We have a Natya Shastra compiled by Bharat Muni. We have several stringed instruments, wind instruments, percussion instruments, and instruments that do not require tuning. You see evidence of that in sculptures and so on. The Bansuri flute, which is mentioned Rig Veda, Natya Shastra. There's also a flute in Harappa. Harappa also has got evidence of a flute that is over there. The veena, percussor of string instruments, mentioned in Rig Veda, Atharva Veda, Taittiriya Samhita, Shatapatha Brahmana, Natya Shastra. So we see an evolution of veena over there. Here's a figurine showing the veena. There's a gentleman in New Delhi, I believe, who's recreating Harappan music by taking Harappan sounds and recreating instruments. For example, this bull, and creating this. His name is Shail Vyas. Look him up, and he's got some very interesting works that he's doing. Nadaswaram. Nadaswaram is an ancient instrument used in southern India, and I believe it could have been an inspiration for the trumpet. It's mentioned in Sangamira Tamil works, as well as in the story of Kannagi in this particular work. Ramanahatha, we know, ancestor of violin. I don't even want to say all these things, but there is a book that talks about the antiquity of this, how the Arabs introduced this to the Middle East, and this rebab. This is the rebab in Cairo, and from there it went to Europe and became the violin. So this is the ancient precursor of the violin. Drums, we find rhythm percussion earliest is in China, 5000 BC. We find very closely associated with the Shiva symbolism. And the Western claims are 40,000 BC, the flute was invented in Europe, in harp in Mesopotamia, in trumpet in Egypt, violin in Italy, piano and guitar. 35,000 years ago, there seems to be a bone flute from Germany, and there's some skepticism. Is that a flute or that chewing of bones by bears? That's not very clear. And by looking at this, we can't tell the tonal ratio, what kind of sounds would have come. It could have just been sounds, not tones or scales or any such thing. 8,000 years ago from China, in a grave, they found these bones from this bird. Bird's bones are hollow, remember. So they used the bird bones to make flutes. And he appeared to have a 7-hole, having a rough scale with a modern octave. So that appears to be there in China from 8,000 years ago. I think that if we look at China, that's a good mirror to what could have been in India, because Chinese were strongly influenced by Indians. So if you find it over there, there's a good chance that it could have been influenced by India too. So here's a grave where they found the flutes. In Sumeria, this particular article, she says that the earliest scores are there. Scores are where you communicate your musical information using notes. So she claims that a particular work in cuneiform turned out to be a musical score in the Lydian scale. Egypt, we see evidence of music and dance, and once again evidence of lute in Egypt, a very ancient period of time. From Greece, 1300 BCE, you find some evidence of the earliest lyre with 7 strings held by a man. We know about the Hemachandra numbers, how it leads rhythm patterns, very recently popularized by Manju Bhargav. Mathematics of music leads to rhythm and scales. So he talks about how the short syllable is 1 beat, long syllable is 2 beats, and the problem of how to fit in a certain number of beats into an 8-note interval and so on. That gave rise to enormous numbers of binary ways of doing these things. So he talks about that. Look at Poetry, Daisies and Cobra by his work. You can see that. Or you might listen to this B.C. Manjunath, who does an amazing performance of this Fibonacci sequence in this conical rhythm pattern. Again, the idea is that in India, mathematics was deeply tied to rhythm with music and other such things. So concluding remarks, roots of music in Samaveda, division of octave, Shruti and Swara is as ancient as Chandogya Upanishad. 3-note to 7-note music evolution via 5-note, examine Pythagorean music. I propose a study of Silva Sutra to show evolution of scale in Western music, antiquity of instruments, and showed connection between math, prosody, and rhythm. And this is my big conclusion over here. We talked a lot today. I'm not sure whether I succeeded in communicating or putting you to sleep, but at any rate, Indian civilization arcing back to enormous antiquity, we traced knowledge systems, showed methods of Indian astronomy, antiquity in astronomical measurements, and we talked about some astronomers, antiquity of medical systems, impact on all ancient modern civilizations, root of mathematics in Vedic era, medieval mathematics, transfer to West Asia, Europe, And present day narratives use faulty, biased methodologies and do not acknowledge Vedic Hindu history or contributions. So that is the grand end of my talk. Thank you very much. Thank you. Thank you. Thank you. Thank you.